All right. In this video, let's talk about how I built a similar environment to Node.js. So we already know that Node.js is basically a JavaScript runtime environment, which is basically used to execute JavaScript, right? So that's okay. And we will also try and understand how things like, for example, in Node.js, we have got a lot of modules. So these are very, very essential modules and kind of, whenever we deal with the server side code, so they are the kind of bread and butter of the server side code that we usually write. So modules such as file system, modules such as HTTP module, or let's say if you are dealing with something like hashing or encoding kind of stuff, then we have something called crypto modules. So if we go inside any one of these modules, such as file system, there are a lot of methods in there basically. So let me just go and let me show you. There are methods such as read file, which basically accepts a path and few options, and they help us basically read the file from the file system or from your local system, right? So how are these modules implemented? What goes inside these functions which are being written in Node.js, right? So what I have done is I have created a very similar environment to Node, and I have called it MICRONODE. So if you're someone who is like little bit familiar with Node.js, or if you are just a beginner, you must have at least heard about Node.js. So Node.js is basically an environment where JavaScript is executed, and it contains few components. There are few components which are involved, and they are kind of heart of the heart of the Node.js. So for example, there is something called V8, and to handle all the asynchronous operations, or you can say the IO operation, we have the another very, very important component called libuv, right? So this is the typical Node.js architecture. So in this video, we will be looking at this interaction. So I'm more interested in understanding how the JavaScript engine basically consumes the JavaScript code and executes that code at the lower level, right? So what I've done is I have created this tool called MICRONODE. So it's kind of a very similar environment that of Node. And what I've done is I have added a QuickJS, or you can say it's a JavaScript engine. It's a very lightweight JavaScript engine written in C. So what I've done is I am using this QuickJS engine, which is kind of analogous to V8, and we will be executing our own JavaScript code using QuickJS. And let's see how this whole environment is created. So what I'll now do is I'll just deep dive to the code, and let's see how these things work. So if you see right over here, what I have is a MICRONODE folder, and there are few files. So one of the thing is something called QuickJS, right? So let me just show you. So QuickJS is basically a JavaScript engine that we are using. It's very lightweight, written in C. So you can also just clone it from the GitHub, and you can also start using it and build out your own tools if you want. All right. So now what we have is we have another file called micronode.cpp, and this is literally your own Node.js, right? So when we say JavaScript runtime environment, what does that mean? So that simply means a kind of program only, right? So it's a program which basically executes a JavaScript, right? And you can see there are like same very, very familiar kind of code, very, very simple code. It's kind of C++ code. If you are from C++ world, you might have seen these syntax and all of this. So there is a main function, and then there are few things written right over here. So we'll go through the code line by line, and we'll try and understand how this node or a MICRONODE environment works behind the scene, right? So this main function is basically a kind of entry point to the whole environment, right? So this is the first function which gets called, and then it receives few parameters right over here, argc and argv. Argc is mostly concerned with the number of arguments that you are getting while executing micronode.cpp. So it's a cpp or a C++ file. So when you're executing it, so what we can do is, along with the execution, we can pass few arguments such as the file that we want to execute, let's say, right? So I'll show you the demo as well. We'll come to that as well, right? Now, the argv is basically contains the data or the actual argument value. What is the argument that is being passed? So that is fine. So we are just checking that you are passing the file or not when you are executing the micronode tool that we have created. All right. So now the next thing is the create JavaScript runtime and context. So JavaScript runtime is basically an instance of a JavaScript engine. And then what we are doing is we are creating a context. So if you are from JavaScript world, you might have come across this term context. So in JavaScript, everything is kind of executed inside a context. You can think of it as a kind of a box or an object where all the execution takes place. So that is what we are creating, a context, and we are using C++ pointers to basically point to these objects. So that is what these lines mean. Now the next is the init modules. So this is where we are defining our own modules, very similar to the Node.js, right? All of these modules, they are also defined in a similar way. So let's go and see how these modules are being defined. So you can see right over here, we are grabbing the context, and then what we are doing is we are grabbing the global object. Now, from where we are getting all of these functions such as JS runtime and new context, JS get global object. So they are being provided by the QuickJS library or the QuickJS JavaScript engine that we are using. So you can see what I have done is in my micronode tool or in my micronode.cpp file, I have kind of plugged in the JavaScript engine. And these are very common libraries provided by the C++. Again, very simple libraries. So IOStream is mostly for input and output. FStream is for dealing with the inputs again and file reading files and all of that. Then this is the vector, which is a kind of data structure. CMath library for providing the mathematics or mathematical utilities. So that is okay. Now let's go back to the init module function. And what we are doing is we are creating a kind of objects, right? So these functions which are being provided by the QuickJS library, they help us create the JavaScript version of these objects. So underneath these functions, there is a kind of C++ code which is being wired and which basically help us create the object, and then we store it inside the variable, right? So this is the kind of new object which is created. And then what we are doing is we are attaching a method to these objects. So for example, let's say if I go to crypto modules, right? Or let's say if you go to file system, then you can see there are method attached to the fs, right? So that is what we are doing right over here as well. So we are basically kind of attaching the methods such as log method and the value of this method. So this is the name of the method and this is the value. So this is nothing but a new C function, right? So this is how we wire basically the utilities or the JavaScript engine with the actual node or micronode tool in our case. So what now I am doing is I am basically creating a new function, and what I'm doing is I'm passing few arguments right over here, and it basically points to the JS console log. So inside console, I have defined a log method, which basically help us log anything onto the console, right? So this is the implementation of this log method. And this is where we have written how to log any message onto the console. And trust me, this is the most easiest method you would have seen. So you can see right over here, what I'm doing is I'm grabbing the whole array, right? So argv is mostly used for getting the arguments and all of that, right? So we are storing the array inside the message pointer, and then what I'm doing is I'm literally doing C out. This is the most easiest statement, or the first statement that we usually write when we write a C++ code. So it's a very, very simple C out statement, and we are printing the message. And then we are doing JS free C string. So this is basically done in order to free up the memory, because we know that in C++ there is no auto garbage collection. So it's a kind of developer's responsibility to free up the memory or to perform the cleanup. And then what we are returning is we are returning the JavaScript version of undefined that you might have seen while doing the console log statements. So let's now compile this whole code, and then we can go through the other modules as well. So let's go in here, and then what I'm going to do is I'm going to use this command to compile my micro CPP code. And this is a kind of linking step that we have. So what we are doing is we are kind of linking this QuickJS library with our micro node.cpp file, and we are using the C++11 standards, and this is the compiler, the C++ compiler that we are using. And then what we are doing is the output of this compilation is basically the result of this compilation is kind of stored inside this file called MICRONODE. So this is a kind of executable file which can be directly executed onto the machine. And then there are few options that we are passing related to threads and all of that. So you can just do Google search for these options as well if you want. Now what I'm gonna do is I'll just compile the tool, and you can see the compilation is success. And you can see right over here the micronode file is created. So this is the kind of executable file which has resulted from this micronode.cpp. So this is literally your micronode, or you can say an environment or a file or a program similar to Node. So this is your actual Node. Now what I can do is I can just execute some code. So what I have done is I have a simple index.js file wherein we can do console log, and I can say hello from micronode. So that's okay. And let's see if we are able to execute this. So what I can do is I can say micronode index.js, and you can see we are able to print that message. So this is our own implementation of console log method. You can define other methods as well if you want, such as console log warn, console log error, and you can then use the things like C error and all of that, right? So that's fine. That was easy. Now let's see a few more implementations of modules. So there is another module which I have defined called utils. Now utils method is a kind of my own module, and it has got few methods such as add method. So this is used to add two numbers, let's say. So again, what I'm doing is I'm setting this property to utils, and then I'm saying that create a JavaScript function, create a new C function, and then what I'm doing is I'm passing the reference to JS add. There's the name of the function and the number of argument it is expecting. So it is expecting only two arguments because we are doing arithmetic sum of two numbers only for the simplicity. Now, if we go to JS add, you will see we are basically checking, okay, how many number of arguments are being passed. So if there are less than two arguments, then we are just throwing the error right over here. And then we are also performing few checks, such as whether the arguments which have been provided are the JavaScript numbers or not, right? Then what we are doing is I'm just declaring the C++ variables A and B, and then I'm storing the reference of argv0 and argv1 into the A and B respectively. And then we are performing a plus B operation, the arithmetic addition, and we are returning that result as a new integer, and that is the JS new integer. So this is a JavaScript value which is being returned when this code is executed. So that simply means when you will execute utils dot add, and let's say I'll do 4 comma 5. And what I can do is, let's say sum, and let's print the value which is being written. Console log of sum, right? So if we go right over here, so you can see we are able to print 9, which is the correct answer, right? So this is how this add function is kind of implemented inside a utils module. Similarly, if you want, you can have your own method as well. Let's say if you want, we can define a power method, let's say, right? So for example, if I go right over here, what I'll do is I'll just call it JS power. So I'm just writing it to just give you a hang of how you can define your own methods very easily. So again, so what I'm gonna do is I'll say JS power. So what I basically want to compute is a raised to the power b, or you can say, for example, if you want to have something like 2 raised to the power 5, so we should get something like 32, right? Which is the 2 raised to the power 5. Now, in this problem, what we have is we will have again two arguments, that is a and b. So these checks I'll keep as it is, and this will also remains the same. Only this part will change. We have to compute a raised to the power b now. So what I'll do is I'll use a built-in method provided by the C math library, and I'll just write. Okay, I'll have to write here. So I'll simply say POW. So that is the method provided by the C math, and I'll just say a comma b. So this is the JS power method which can compute the a raised to the power b, and I'm going to register this function inside our utils module. So what I can do is, the way we are registering the add method, very similar way we can register the power method as well. So that's okay, and we will give the reference to power method like this, and we are attaching the power method inside the utils, and we are attaching the utils inside the global object, so that when we write something like utils.add, it get resolved in the global space. So that's okay. Let's now see. Let me call it result utils.power, and I would say, for example, 2 raised to the power 5, and we can just say console log of result. So let's go. And since in this case, what we have done is we have added a new method, we'll have to recompile the whole environment again, right? So what I'll do is I'll recompile it, and let's execute it now. So you can see we are getting 32, which is the correct answer. So this is how you can define your own functions inside these modules, and this is how these modules are created in Node as well, right? So that's okay. Now let's go and see one more method, that is the sort method. For example, let's say I want to implement my own merge sort, right? So what I've done is I've created an algo object, and onto the algo object, what I'm doing is I'm defining my own merge sort, and this basically this is the implementation of that merge sort, which I have written inside JS my sort. So if I just, let me just close these. If I just expand this, there are few checks again for the arguments and all of that. And then what we are doing is we are creating a vector, so which is an array only, right? And then what we are doing is we are performing a merge sort. So if I go to this method, so you'll see this is literally the merge sort that you might have written hundreds of times whenever you are writing algorithms or learning DSA and all of that. So you might have seen this code a lot, right? So this is a simple recursive divide and conquer algorithm used to generally sort the arrays, right? So, and this is the corresponding merge function that you might have seen. So that is it. And then once the sorting is done, what we are doing is we are creating a new array, and then we are putting the result inside that result array, and then we are returning it right over here as a JS value, so that you can basically store it some variable. So what I can do is I can define an array, or let's say I'll do nums and I'll say 2, 3, 1 minus 8, or let's say 5 more values, just fine. And now what I can do is I can say sorted arrays, and I'll say algo dot merge sort. So this is the method that we have registered over the algo module. So the algo module is the merge sort method, and then I can pass the nums array, and I can say console log sorted arrays. So we go right over here, so you can see we are able to sort the array in the ascending order by default, right? So this is how these methods are being registered inside the module. So I think now modules part is clear. So how these modules are being registered, how those implementations are being done for those methods and all of that in C++ or in a low level code. So that's fine. Now let's see one more thing, how this node or a micronode tool that we have developed, how does it basically understand this code, right? So let me just give you a glimpse of how this is being done. So you can see once the registration, or once we have registered the modules, the next step is we are basically reading the JavaScript file. So when you basically write micronode index.js, you're passing this as an argument in the execution of micronode, and this file is basically received right over here. And then what we do is we basically read this file using the built-in C++ methods, and we store it inside the script. And then what we do is we are passing this script, that is this whole code, to the method called JS_eval, again provided by QuickJS. So, and then it basically executes that code. I'll go into what goes inside it at a high level. We'll discuss that. But if you want me to create a very detailed video on how things work inside the QuickJS, or how it evaluates everything line by line, so this will require some knowledge around compilers and interpreters, how they work, what are the different stages which are involved in the execution. So I'll just give you a high level view for now, but that's okay. Now once the execution is done, it returns the result. If that result is kind of exception, then we print the exception and we basically stops the execution, right? And finally, we free up the context and the result. We free up the result from the context, and then finally we free up the context and the runtime, and return 0 means success. The whole code is success if there is no exception in the JS_eval function or in the execution of index.js file. Now, let me just take you through the steps involved in there. So inside JS_eval, there are few things which are being done. So these are very classical steps which we usually see whenever the code is executed inside the compiler, interpreters, and all of those. So you can see there is this first step is basically there is something called lexing. So lexing means we basically split the code into tokens, right? And then those tokens are basically passed, and we create something called AST. So all the syntax checks and all of those are being performed, and then that code is basically converted into a low level, that AST is basically converted into a low level byte code, and then that byte code is basically executed by the machine, right? And then it finally it checks for any runtime errors, the errors which may occur during the execution itself, and accordingly it returns the result. So these are all the steps which are involved inside the JS_eval. So that is all about how this tool works. So yeah, that's it. That's about how I was able to create it. I hope this was helpful understanding how would Node.js be working behind the scene. So if you're interested in such videos and such topics, so comment below and I'll create more videos around behind the scene stuff and all of this. So this is it. This is all about this video.